right. Let's summarize what Fourier series is. What are the three different forms that we actually looked at? So let's look at them and let's summarize this. So the first format that we looked at, format 1 of a Fourier series that we looked at, is actually f of t a naught plus n as it goes from 1 to infinity. An goes 2 pi n f0 t plus bn sine 2 pi n f0 t. All right. So we're going to start off with format number 1, and we're going to see how do you actually, what is the actual format of that, and just quickly summarizing it. So in order for me to calculate a naught was given as 1 over t with respect to t, f of t dt. All right, this is how you calculate a naught, which is actually your DC component. To calculate these an and bn terms, we need to just simply take an, which is 2 over t. Let's integrate that with respect to time. F of t goes 2 pi n f0 t, and bn is 2n t, 2t, sorry, sine f of t sine 2 pi n f0 t dt. All right, dt, I forgot to write dt. All right, this is the basic format. This is the one that we use to try form number 2, format number 2, format number 3. This is how we normally do it. So format 2 that we looked at, which was actually a complex form that we looked at, that was defined as to be f of t, which is c naught plus summation n goes from 1 to infinity. Cn goes 2 pi n f naught t plus theta n. And let's just to recall what these terms are. C naught is your a naught. So the way you're going to calculate C naught is just the same way you're calculating your a naught. Cn was given as the magnitude of these terms, an squared plus bn squared, because if you remember it, in order for me to come up with this, we use our favorite trig identity in format number 1. All right, I just want to quickly go over this. With theta n, if you recall this was actually a tan minus bn divided by an, and this is actually a fourth quadrant tan function. All right, where n is actually 1, 2, 3, 4, and so on. This was your format 3. And the last format that we actually looked at it in our last video, which is format 3, that is given as f of t summation n goes from negative infinity to positive infinity, x of n e to the j 2 pi n f0 t. That's it. This was our simplified form, which is known as format 3, however you want to call it. And we know we actually use format 1 to actually come up with this. X of n, this is just 1 over t, f of t e to the negative j 2 pi n. I think it's negative, yeah. It's negative j 2 pi n f naught t dt. All right, so these are 3 different formats that we use in Fourier series, and based on these formats we can convert a signal from time domain to frequency domain. Okay, one thing that you need to remember, that Fourier series, we're gonna use it is mostly for periodic signals. After this, what we would like to do, we're gonna do an example on this. We're gonna do an example how we can come up with how we calculate a Fourier series for a periodic square rectangular square periodic rectangular signal, we're going to calculate a Fourier series, and we're going to break that uh, rectangular signal into we're going to break that rectangular signal into sinusoidal and cosinusoidal component using my Fourier series. So if you have any questions, please leave it in a comment section. If you have any suggestions, leave it in a comment section, and don't forget to subscribe to my channel.